Right. Hello friends, welcome to my channel. In this video, we are going to discuss about multiplexer. Right. So in our previous video, we discussed about encoder and decoder. Now we are going to discuss about multiplexer. So here, the multiplexer is a special, versatile, and one of the most widely used standard circuit in digital design. So it is a combinational circuit having many inputs and a single output, and we can say that there are different names are there for this multiplexer. So those are nothing but data selector, and we can also call it as a many to one circuit, and it is a universal logic converter. So why it is universal logic converter, we are going to see in our upcoming videos. Universal logic converter and parallel to serial converter, and we can also call it as waveform generator. So actually these are the applications of multiplexer. Now let us see. So here it is a data selector, like many to one data selector. We can also call it as many to one data selector. So simply you need to remember that multiplexer having a only a single output. This is fixed. Only one output is there, single output multiplexer. So here I0, I1, I2 and I3 four inputs I am considered, because it is a 4 by 1 multiplexer. Now we are going to discuss with example 4 by 1 multiplexer. That means it is having four inputs, and these are the four inputs, and this one, it is nothing but the output, right? And the multiplexer operation completely, it is decided by the another two inputs, that is selection lines. So here S1 and S0 are the selection lines. The selection lines plays a major role to control the operation of this multiplexer. So now let us see with the help of truth table that we can understand easily. So here the selection lines are very important in multiplexer. So now the selection lines are 2 in 4 by 1 multiplexer. For example, this 4 we are going to represent it as 2 square, means 4. So now these 2, like power of 2, so which is nothing but the selection lines, right? So that is the reason it is the two selection lines are required. So for 4 by 1 multiplexer, so here the input combinations I mentioned here, and S1 and S0 are the selection lines, and Y is the output. So here that point you can also observe here, the select lines will determine which input is connected to the output. Now see truth table. For example, the selection lines are 0 0, I0 is activated, that means I0 is passed to the output. For 0 1 combination, I1 is passed at the output side. For 1 0, I2 is passed at the output side. For 1 1, I3 is passed at the output side. That's it. So that is the meaning. The selection lines will decide the which input is passed to the at the output side. Based on this, now based on this, we will write the one important equation, multiplexer equation. Like for example, it is a 4 by 1 multiplexer equation. So by the above the function table or truth table, you can easily write this, like 0 0, like we already know 0 means in min terms it is, we are going to represent it as, for example here S1 bar, right? So 1 means we are going to represent it as S1 only, right? For example, in the same way, 0 0 means S1 bar into S0 bar into I0 plus 0 1 combination S1 bar S0 into I1 plus 1 0 combination, 1 means S1, 0 means S0 bar into I2 plus 1 1, in 1 1 combination I3 is activated. So that means output is I3. So like that, S1 and S0 into I3. This is our complete the 4 by 1 multiplexer equation based on having the selection lines, like 0 0 combination, 0 1, 1 0 combination, 1 1 combination. Hope you understand. If 0 is there, that is bar. that you can observe here. Now this is the logic diagram. Based on this only we can easily implement this logic diagram. So here in the output equation it is containing sometime it is, you may observe that S1 is there, S1 bar is there, and here S1 is there, and S0 bar is there, and here S0 is there. So that that inputs, that selection lines I mentioned here, and this is the S1 line, and this is the S1 bar line, and this is S0 line, S0 bar line, and then the inputs, you may observe the inputs here, I0, I1, I2 and I3. So if the based on the selection lines 0 0, so this is the 0 0, so 0 0 combination I0 is there, so these three will be activated at the output side. So this is the OR. If at least one input is 1, the output is 1 for the OR combination, for example. So if all these are not activated, if I want to send only I0 input, so now I am enabling the I0, and the remaining these I2 and I3, I1, I2 and I3, I make it as 0. So AND gate will be 0. Here it will be 0 only. This one is the logic one at the output side, and this is the OR gate. So the I0 is passed at the output side, like that. Similarly I1, it is connected like 0 1, like a S0, S1 bar, S0, I1. So this is the S1 bar line, and this is the S0, and this is the I1. Similarly 1 0 1 1 also you can observe, 1 1 S1 S0 I3. So this is the S1 line, this is the S0 line, and this is the I3. So this is the way we need to implement the logic diagram also. So for any combination circuit, please remember these three. So you need to draw the block diagram first, block diagram representation. The second one is the functional table or truth table, and the next logic diagram. These three compulsory. Similarly, for your understanding purpose, just I make it here 8x1 multiplexer also you can observe here. This is the 8x1 multiplexer. I told you. So 8x1 means this is the, all these are the inputs and these are the outputs. So you can observe here I0 to I7 are the inputs, and Y is the output. Single output. Mux means single output. So many to 1. You can also call it as many to, remember like this, many to 1 data selector. So here 8x1, this we can represent as 2 power 3. These 3 which is represented as selection lines, like S2, S1, S0. Here treated as S2 is MSB bit and S1 is the LSB bit. Based on that, draw the truth table, place S2 here, this is the MSB bit and this is the LSB bit, like 8421. So like start from 0 to and 7, 0 1 2 3 4 5 6 7. For example, if I want to activate I0, so 0 0 0 I will keep it as. For example, I want to activate I3 at the output side, so my selection lines must be 0 1 1. For example, I want to select I7 at the output side, I want to pass only I7 at the output side, I am going to keep it as 1. Selection lines S2 is 1, S1 is 1 and S0 is 1. So that I7 it is passed to the output side. So hope you understand. This is about the block diagram and truth table and the equation. So equation also based on this only, the equation it is implemented. Hope you understand. Like 4x1 mux only. And finally, this is the logic diagram. So here S1, S2, S1 and S0 you can observe here. So the I0, I1, I2, I3, I4, I5, I6 and I7 the inputs I am considering here. Then so for example, so here when I0 is selected, if it is S2 is 0 0, like this is 0, this is also 0 and this is also 0, so I0 is selected, right? and that means here in this line what are the outputs, we can say that here output is S2 bar, S1 bar, and this one S0 bar into I1, because it is AND gate, into I1. This is positive here. And what is the second AND gate output? Let us assume this is the first AND gate and this is the second AND gate. Second AND gate output is, which line it is connected? S2 bar it is connected. So S2 bar, here it is S1 bar, and here it is S0, and into I1 is connected, I1, like that. So this will be passed at the OR gate. So that is the reason. So it is OR, that means addition. That's why in our equation, in our equation contains like a plus symbol here, like this. Hope you understand. So this is about the multiplexer. Here we discussed the 4x1 multiplexer and 8x1 multiplexer. So hope you understand. So this is the very important combinational circuit, the multiplexer. Thank you. Hope you understand this. Please like, share and subscribe my channel. Thank you.